Well, there are a lot of really neat applications for matrices, and this is kind of a fun one right here. So this one says that here I have a figure shown, and this figure is a 9-pixel 3 by 3 grid. And if you didn't know already, and if I didn't tell you already, all of our digital images that we are used to seeing on our technology are comprised of a grid with pixels in it. So if you take a picture on your camera, you would end up with a grid that would be some size, and you could assign each of the pixels their own individual colors, just like what we're going to do here. So you can manipulate that picture, and when you do, you're basically running matrices in the background. So how does that apply to this example? Okay, so I have the figure L given to you right here, and the corresponding gradient value for each of those squares is given in the next screen. So the question says that we want to find a matrix that represents the digital photograph, that should say, for letter L. Okay, so if I have a 3 by 3 grid, what are the numeric values that represent the colors that are there? So I know this is going to be a 3 by 3 matrix, and I know that this would be considered light gray. So for each light gray position I have a 1, and for each dark gray position I have a 2. So I don't think you can see those 2's there, but this would be a 2 1 1, 2 1 1, 2 2 1. This is a numeric representation of the picture that you see over there. Now the second part of that question says, okay, well, we want to increase the contrast of my picture by changing the dark grays to black. So all of these dark grays are going to change to black, and the light grays are going to change to white. So we're changing it from a grayscale to a black and white. And I'm going to use matrix addition to accomplish this. Well, I kind of approach this a little bit differently maybe than matrix addition. If I start out with a matrix here that is 2 1 1, 2 1 1, 2 2 1, and I want to end with a matrix where each of the gray positions are a 3. So that's going to be 3 3 3 and a 3. And all of the light grays are going to become white, so zeros. So 0 0 0 0 0. Well, what would I have to do to the original matrix to end with this matrix right here if I wanted to use addition? So I am going to add what to the original matrix to get the new matrix. So I would have to add a -1. No, I'd have to add a 1, because 2 plus 1 would have to be 3. 2 plus 1 would have to be 3. 2 plus 1s have to be 3. Okay, now for the 1 positions, I have to subtract 1 to get a 0. So -1, -1, -1, -1, -1, and I'd left off that 2 plus 1 has to be 3. So in order for me to go from a grayscale matrix that's represented here to a black and white matrix here, I would have to adjust the matrix by adding these numeric values to it. And technically that is what's going on when we make those kinds of adjustments on whatever type of photographic editing software that we're using. So it's kind of a neat concept for you to be able to apply matrices.